Hey, we're OtoAI and we're developing a digital otoscope that uses a novel machine learning algorithm and photo information to improve upon the traditional ear exam for patients and physicians. So, otoscopes are what doctors use to conduct ear exams during a routine checkup. The primary problem that we're trying to address is that physicians are basically tossing a coin when trying to predict whether a patient has an ear infection or not, and are really only accurate about 50% of the time. This is an extremely low percentage. Some of the factors that have led to this low percentage are that otoscopes currently don't have any mechanism for capturing images, and PCPs themselves are not trained to recognize ear pathologies. COVID-19 also places an emphasis on minimizing patient contact, as traditionally the physician would be right up against the patient's face when conducting the exam. And so now Yash is going to talk about what our solution, OtoAI, entails.
Thanks, Nikhil. So currently, there are no other FDA-approved otoscopes on the market that meet the challenges outlined previously. Rather than a simple instrument, the Utopia would be a next-generation otoscope that utilizes modern-day technological advances to capture images and assist PCP with making real-time diagnoses of ear pathology. Enter OtoAI. At the click of a button, our otoscope captures an image of the ear and displays it in our user interface. Once the physician has selected the desired image, our trained deep learning algorithm classifies the pathology as normal or abnormal and generates a report that can be directly uploaded to the hospital EMR system. Our product outperforms current market otoscopes in three key areas. First, we provide better technology, enabling image capture and software enhancement to improve the quality and lighting of the image. Second, accurate diagnoses using deep learning algorithms enable us to reach around 90% classification accuracy on normal and abnormal ear pathology. And finally, our product is telemedicine friendly, allowing seamless data storage, transfer, and integration with the EMR system. Our product was designed to mimic the form factor of traditional otoscopes, ensuring a comfortable and familiar experience for physicians. Jonathan will now talk about the hardware and software design process.
Thank you, Yash. Last semester, with our minimum viable product, we proved that we can use an ear cleaning endoscope to capture medical quality images of the inner ear. Then, using a CNN or convolutional neural network, we were able to classify our pictures of the inner ear with an accuracy greater than 60%. Since then, our product has made significant progress. We changed our model to a transfer learning CNN, which uses information from a more robust and previously trained network to pick features, and this led to more than 25% increase in our model's accuracy, which we then rigorously tested. We also designed and created an easy-to-use encasing and fully integrated our device with a clean desktop application. We have created a fully functioning digital otoscope. We found that images could be captured using a low-cost ear cleaning endoscope. We were then able to enhance those images to allow for better visibility of the tympanic membrane and the ossicles behind it, which are important landmarks in diagnosing ear pathology. We then fitted the endoscope with familiar encasing, which we designed and iterated on with the help of our clinical partner, Dr. Stephen Elitis. We also added an adjustment screw to allow the physician to adjust their entry angle, which is important for different size and shaped ears. Attached to the head of our device, you can see a plastic speculum in black. This is a disposable part, which is readily available and FDA approved. After more testing, we decided to add a soft touch button, which makes it easy for doctors to begin to use the device with just one hand. The OtoAI software is based on a 2,000 plus inner ear dataset gathered from patients by ear pathology labs across the country. Our first step was to augment this data by randomly rotating and changing the exposure on the images to synthesize a 9,000 plus inner ear dataset. We then created a transfer learning based convolutional neural network and iterated on parameters while consulting with PICS professor Paris Perdicaris. When we were satisfied with our algorithm, we began to test based on our own ears and many images of ears off the internet, both normal and abnormal. We generated heat maps of where the algorithm attributed the majority of its decision making on the image and confirmed both the heat maps and the final decision with our clinical partner, Dr. Stephen Elitis. We then developed and iterated on a fully integrated user interface, which allows users to view live video feed of the inner ear, capture multiple images, and choose the ones that they want to classify into a report. We will now show a brief demo video of how our device works.
We're going to be conducting the ear examination with the Otoscope. The first step is to just launch the application and enter in the patient information. From there, a window will pop up that allows you to choose the folder that you want to have your image stored in. And then from there, you can take your Otoscope and insert it into the patient's ear. You can click the button whenever you're ready for your image to be taken, which I just did, and then you can choose the image to generate the report. Once you generate the report, a PDF will pop up, and that has the classification diagnosis.
We evaluated our classifier against a set of 2,000 otoscopic images that were scraped from publicly available databases. We allocated 70% of the images for training the classifier and 30% of the images for evaluating the performance of our classifier. We were excited to see that the OtoAI classifier was 90.32% accurate in identifying abnormal ear pathologies that require further checkup with an ENT. Currently, PCPs are only able to correctly diagnose abnormal ear pathologies 50% of the time using otoscopes, and so our validation accuracy provides a substantial improvement to the current state of the art. Now, more than ever, is the perfect time to bring OtoAI to the market. Given the pandemic, there has especially been a need to reduce doctor visits, but even post-pandemic, a reduction in doctor visits can maximize patient interactions and allow physicians to optimize their time as well. Furthermore, physicians or hospitals are also more willing to engage in telemedicine and digital health, and so OtoAI can really capitalize on this transition. In general, this device is intended for primary care physicians who do not have the proper training to effectively use an otoscope and make accurate diagnoses. Within PCPs, there are two subdivisions: PCPs at large public hospitals and PCPs in private practice. The PCPs at large public hospitals will be easier to reach as we can capture large groups more effectively. The private practice PCPs, on the other hand, are going to be a little more difficult as this would require individual pitches, and so moving forward, we will definitely try focusing first on the PCPs at large hospitals when getting this device out. And next, Uday is going to take it away and talk about the market size.
Thank you, Krishna. When examining the market size, we can see that the United States otoscope market size for the traditional otoscope as of 2021 is $100 million. There's 6,090 hospitals in the US, and there's 209,000 PCPs, of which 49% are private practice. Moving into the business model, I'd like to point out that OtoAI leverages this Tesla model to create two sources of revenue. Our first source of revenue is the upfront hardware, or the device that you saw earlier in the presentation. We'll be pricing that at $80 per otoscope, which compares very favorably to the traditional otoscope, which costs $200 currently. The device costs us $56 to produce, giving us a profit margin of 43% per device. In addition, we have a second source of revenue through software, which we price at $5 a month, and users will have to subscribe to the software in order to access new capabilities and new data additions. The software actually costs us nothing to produce since it utilizes open source resources. As we look towards the future, there's 4 major steps that we need to do between now and product launch. First, we need to conduct a clinical trial at HUP sometime in Q2 of 2021. Then we will move on to seeking FDA approval for our device, which would take about 3 months because our device would fall under Class 1 designation. We will then be advancing our software to allow for diagnosis of specific ear pathologies beyond the abnormal normal scope that the device currently provides for. And finally, we will be looking to partner with hospitals by Q4 of 2021 in order to get our device into the mass market. Before concluding our presentation, we'd like to thank Dr. Stephen Elitis at HUP for being our primary clinical mentor. We'd also like to thank Dr. Paris Perdicaris for helping us with our ML algorithm. Dr. Meany, Dr. DePaulo, Seville, and Melanie, our TA, were instrumental for the development of OtoAI. With that, I'd like to conclude our presentation. This is our contact information. Thank you for listening. We are OtoAI.